Hey, it's your old pal Lucid Stew again with another Dream Streams breakdown. This time we're going to talk about the Made by the Molecules stream on September 12th. In this stream, Media Molecules showed off some games made by team members and also explained a little bit about how they were made. We're going to start off by looking at some of the load times for various games. It's worth noting these are all loaded locally, so playing from the Dreamiverse will probably vary, but still they're pretty quick. This is for Rovium, and in case you missed it, that loaded in 2 seconds, and we're through the game start menu and playing within 5. Next up is Moon Raiders. Load time is 4 seconds, and into gameplay. And lastly, Hammertime. This game is a little more complex and actually contains 3 mini-games. Load time is 7 seconds, and the game is playable within 12. Overall, pretty encouraging, especially for linking worlds instead of trying to pack everything into one. Next up, we're going to look at some object menus. It looks like strokes have been renamed paintings, although they still refer to them as strokes in the stream. You can see they're concentrating more on polish at the moment. The tabs in the menu have gone from being numbers to icons. Also, we're seeing some tooltips when hovering over a slider, both encouraging signs that we'll be playing Dreams soon. By the same token, what was formerly known as a model is now a sculpture. Other than the name change and the tooltips, I'm not seeing any differences from previous examples. You can use a grouping gadget to funnel a signal from a single source to multiple elements. You can do this normally, but this is a good way to organize things. If you look at the wires and gadgets in these examples, you can see that organization is going to be important for anything of any sort of logical complexity. Here's a first look at the inside of a mover. You can use a mover to change the position of an object in 3D space. Unfortunately, we only see the first tab, which isn't particularly useful in deciphering everything it can do. The first slider is forward speed, the second is forward strength, which to me implies acceleration, and the third is overall dampening. Dampening should also affect acceleration and deceleration, so I'll have to see this in more detail to give you a better idea. If you have a clue, maybe from experience with LBP, leave a comment. Also, this gadget isn't hooked up to anything in the microchip, which should mean the gadget's effect is constant. This is a force applier. This is a bit different than moving things directly with a mover because you're leaving it up to the physics engine to decide what happens to the thing after the application of the initial force. The basic way it's set up will allow you to apply force to certain things within a certain zone. You can see from the last tab that you'll be able to use tabs to filter out things you don't want to affect. In this way, you could have something like area of effect damage with a knockback that only affects enemies. And last but not least is squashiness in the sculpture menu. This allows you to simulate some fairly involved keyframe animation when an object impacts another. When turned up, the object will deform in a cartoon fashion in order to give an extra impression of impact. This is an animation standard for a lot of different things, so get ready to use this quite a bit on your sculpts. Okay, now that the simpler stuff is out of the way, let's look at some microchips. As a side note, if anyone from Media Molecule is watching this, if you could please pass a note to not fidget with the controller so much during stream so we can get a better idea of what's happening, that would be appreciated. This microchip is actually fairly simple. There are 3 different trigger zones. Each one causes something different to happen when their condition is satisfied. The top one causes the object to rotate, move, and output a signal after a given time. The middle one outputs a signal and sets the object to a keyframe animation when the condition is not met. The last one simply outputs a signal to something else. This is the main microchip for a text adventure game, and it shows you how organization can work in Dreams. You see a lot of nodes and wires running everywhere, but in reality it's as simple as each node representing a room in the adventure and most wires representing a pathway between those rooms based on the decisions made in the game. Another thing we've seen for the first time is a text displayer. Aptly, the text displayer displays text. The text can be displayed in a 2D overlay, which some might call a HUD layer. It can also display in 3D space. The nice thing about those displays is that they're actually in 3D space rather than appearing in the HUD layer at the apparent 3D location. That's an important difference because the latter would always face toward the camera, whereas this version will face whatever direction it's facing in the 3D space, like any other object. What does that mean? Think billboards. This huge bank of paired counters and transmitters is something of a programmer's nightmare due to the repetition. A general rule of programming is to avoid this, and normally you would craft a function to clean this up, but Dreams is a little more straightforward, presumably for simplicity's sake. This is a bunch of Boolean variables used to determine permanent conditions within the text adventure. A Boolean variable is like a light switch. It determines whether something is off, on, true, false, or however you want to put it. There are two states, one or the other is valid, but never both and never neither. You can use a counter to achieve this because 0 is one state and 1 is another state. The transmitter sends the information to receivers somewhere else in the logic that then use that information to do something else. This is another huge bank of Boolean variables, the difference being the receiver on the upper left. That receives a signal from somewhere else in the logic and then resets all of these counters back to 0, so it's a bit like a reset button. This is the microchip for the player's ship in Moon Raiders. The controls look complicated, but it's really just the controller hooked up to a rotator gadget. There's some interesting logic also in there to allow the player to invert the X and Y control axes. You just run a splitter into a combiner and then flip the wires. There are a couple of other things going on, but that's pretty much it. This is the part that got everyone excited during the stream. The ship uses 5 laser scopes to feel out its environment to produce a sort of autopilot. It's not the simplest thing on Earth, but it's easier to pull off than you might think. Basically, the ship is set to go forward in all directions simultaneously, but the left, right, and up, down cancel each other out, so the ship goes forward when unimpeded. If one of the laser scopes intersects something in front of it, it reduces the forward power to that side's direction, which removes the balance. As a result, the ship turns in the other direction. With those adjustments happening very quickly, the ship is able to navigate a pretty complex space. Hammertime is a game that actually contains 3 mini-games, and it accomplishes this without loading extra worlds. The way that it does this is actually fairly simple. Noticing a theme? Each minigame is powered off and made invisible until it is needed to be played. When the minigame is done, the parts of it are destroyed, and the next one is powered up. In this way, the games can get more complex while keeping up a steady frame rate because the previous games have removed part of the load on the engine when they're destroyed. Hammertime uses invisible walls to contain the action as another trick. There are set pieces in the game that act as scenery that appear to contain the gameplay, but it's actually the invisible walls that do the job. The minigame in Hammertime where the puzzle piece floor is destroyed and then recreated each round looks to be intensely complex, but again it's simpler than you might think. When one of the hammers hits the floor, it spawns an invisible cube which is set moving in the direction the character is facing. The pieces of the floor are static until the cube detects them with a trigger zone. When this happens, the puzzle pieces are made physical and gravity is able to act on them. Because of this, they fall. Easy enough, but how do they get back into place for the next round? That's a pretty cool trick, but still simpler than you might think. When the puzzle piece is detected by the cube, its position is captured and put into a keyframe. After a certain amount of time, that keyframe is active, which causes the puzzle piece to interpolate from its current rotation and location back to the rotation and location values captured when the cube detected it. One last thing we saw in the stream was UI in the 3D space rather than the 2D overlay. This will allow you to do lots of different things, but I wanted to talk about some of the drawbacks. This is Ferrovium. It looks like the ships that represent extra lives and the indicator bars are both in 3D space. It's difficult to see with the MM logo in the way, but you'll see a number pop up in the right hand corner. That element is in the 2D overlay. One of the issues with having UI in 3D space is that it can then be acted on by other things in 3D space, and sometimes this is undesirable. Here, when the ship takes damage, a camera shake triggers, and that camera shake also shakes the UI. This can be useful because it's dramatic, but you also might not want that. You'll also notice the red shock wave from the explosion changes the color of the UI slightly. This can also be undesirable. It's not a big deal, but these are reasons that I hope Media Molecule gives us plenty of options for displaying in the 2D overlay that go beyond text. Anyway, that's all there is for this stream. See you next time.